Hi, and welcome back to E3 Energy and Efficiency with Emily. I'm your host, Emily Mottram, and today we're going to talk about why you might want to build a high performance home. So, we've talked to a couple of different experts in their field. Hopefully, we'll get more in depth with the technology and the science and all of the different disciplines as it applies to architecture and energy efficiency in the future. But we thought that maybe it was worthwhile to just talk about why you might want to build a high performance home. And also that we sort of just jumped into this podcast and I didn't really introduce myself or talk about where I was from or what I was doing. So pardon the headphones today. It seems like spring is finally here, and I think all of the neighbors for the office are mowing their grass today. So I hope you can hear me and I hope the sound is okay. But I just wanted to give you a little background. I am not a native Mainer. I moved here in 2007 with my husband. I grew up in Pennsylvania. I went to Penn State and got my architecture degree from Penn State, and then moved to Washington, D.C. for 2 years, where we flipped a coin and said, your family or mine. He won, and we moved to Maine. I moved in March of 2007, and about a week later, it snowed 10 feet. So that was sort of a rude wake-up call for me, coming from Washington, D.C., where we hadn't really seen any snow for a few years after college. And we also had a rear-wheel drive vehicle that I could not get up my in-laws' driveway. And my mother-in-law promised me, it's not usually like this. Followed by one of the coldest summers that I can remember since I've moved here to Maine. I think there was maybe one day where it was above 75 degrees, and I thought, this is crazy. I am gonna freeze here in Maine. So with that being said, she said, it's not usually like this in that summer. And I then told her that she was not allowed to use the words, it's not usually like this anymore. So for the last 12 years, she has not been allowed to say that. So anyway, I grew up in Pennsylvania in a farming community, and we moved to Maine, and Maine is a cold climate building. I worked for an architect in Portland for a couple of years. And then the market got really bad, and it was considered gainfully unemployed to be an architect during that time. And I thought, what does Maine really need? And that's when I got into energy consulting and energy performance. And I did a lot of home energy auditing, which led to large-scale multifamily energy projects all over the country. And I got really interested in the science behind building, the things that make a house more efficient, and why you might want to do that. We did large-scale projects where, doing simple efficiency measures like replacing a toilet saved millions of dollars for a housing authority that they could then take that money and put it into improvement projects in the entire development. And silly things like, we used to know to face the house to the south. And then when energy got cheap, we stopped doing that. We stopped kind of concentrating on those things. But now I would say that energy is not cheap. We lived with my in-laws for about 6 months while we saved money to buy our first house. Our first house was about 1,200 square feet. It was a single story, very small house. And we had to put $2,500 a year or more into fuel oil, which I didn't really even realize that fuel oil was a thing in rural communities. And when you come to Maine, it's one of the only places in the country that's still using fuel oil. There's not a lot of access to gas or propane. And in a rural community where you are trying to save money, it's a lot cheaper than electric or electric resistance. And back in 2007, 2009, they weren't making heat pumps that went down to the -5 degrees. And honestly, they weren't really building houses that could support using a heat pump as a system that worked. And as far as I'm concerned, we're still a cold climate area, zone 6. We are supposed to have R49 in the ceiling and R21 in the walls and R10 or 15 in the basement, depending on how you insulate it, and an ACH of 7. With visual inspection, and some towns don't actually have to adopt the energy code or the code at all. And we're still in the 2009 code, so that was from 10 years ago. But the efficiency up here for cold climate buildings still doesn't necessarily meet the requirements for what you would want for a heat pump installation system. So we've been building high performance homes with 1, 2, 3, 5 heat pumps, depending on the layout and the space. And we've been using air source heat pumps. We don't do any geothermal. And just trying to reduce the system, but it is possible to, have a house that runs and that performs well. And I stand up on my high horse a lot and talk about the building envelope, because I really feel like that is sort of mission critical. It's the one thing that is super important when you're building in cold climate building, and that should be done, to the best of your ability for what you can afford. Do you need to put solar on the roof? No. If you orient the house, can you do it in the future? Fantastic. If you can't, that's fine. But the performance of your house is so strictly tied to the efficiency, both air sealing and the insulation types that you use, that is the hardest thing to change after the fact, and unfortunately it's not the pretty, beautiful cabinetry, countertops, flooring, furniture, but it's probably the most important thing that you can do. But people don't necessarily want to talk about the performance of the structure. I mean, some do, and some want to get into the weeds and talk about the performance of every system in the house. I actually teach a sustainable design class. A few years ago, I was teaching it. Now that I'm back full time, I am sure Meredith is going to convince me to teach it again. But in the sustainable design class, in the very beginning, I asked the students, what's sustainability? What does that mean to anyone? And they have all kinds of different views that they bring to it. Some people are concerned, like I am, about the building envelope. Some people are actually really interested in the technology, which is fascinating. Automated technology, making it so that you don't have to think about anything. With Wi-Fi performance now, you can have shades that go up and down on their own. You can have lights that turn on and off. You can have motion sensors. You can have all kinds of technology that's really controlled by something other than you. And if you set an algorithm for that, maybe the performance is extremely specific. And so we get into a little bit with the envelope of the structure, and then reducing the amount of mechanicals that we need. Although in exchange for a smaller heating system, you may need to have a fresh air system. And that isn't necessarily a downside. People are concerned. That's another question that I ask at the very beginning of my sustainable design classes: does the house need to breathe? And most people in standard construction are saying, yes, the house needs to breathe. And the answer to that is not as simple as, yes, the house needs to breathe. The occupants need to breathe. The indoor air needs to be exchanged with fresh air. The systems and walls need to dry out if they have vapor diffusion, but it doesn't need to breathe in the traditional sense. And here in Maine, we have some of the oldest housing stock in the country. Back when people owned the back 40 and cut down their wood and had a wood stove, and they just cranked that on high and did the best they could, that was something. They didn't have issues with radon. They didn't have issues with any kind of indoor air quality, because products were coming from somewhere locally. They might have been cut down and dried from the lumber yard kind of next door or off their property. They also were very breezy. They let water and air kind of go through the structures, and they didn't think about that. But then we started building tighter homes, and we also still didn't think about what we'd be trapping inside the house once we started to put insulation or air sealing into the wall systems. So, of course, green building got a bad name when we started creating some sick building syndrome. And we got to thinking about fresh air and where that fresh air comes from. And even in the 1800s, with all of these old farmhouses, the fresh air was coming from everywhere, which meant it was coming from your dirt basement with all of the moisture and wet and dirt and gross. I know I have been in so many basements and people are like, oh, it's gross down there. Oh, there are cobwebs down there. Oh, we don't go down there. But the foundation of your building is very, very important, both for energy purposes and structurally to hold up your building. So it's really critical that you think about the moisture that basement, that dirt floor could be introducing into the house, or the cold air that's coming in. Are the above grade sections of your house not insulated? Do you have daffodils in the spring long before the snow has melted because there's a foot or two around your house that's warm? It's warmed up by those walls, and so all of the air is coming or all of the heat is going out through your basement walls, especially with your older heating system. You have an old oil furnace or boiler, and that thing kicks on and it's hotter in the basement than it is anywhere else in your house. And before it has the opportunity to make it to the upper floors, that heat is escaping out through your foundation walls. And so we wonder why, the warmest room in the house is always the one directly under the heating system, and you can't get heat to other spaces in the house because it's traveling through cold areas and it's cold until it gets there. So that's one of the simple reasons for why you might want to live in a high performance house. I mean, everybody, and I said this sort of jokingly, and I say this a lot in networking meetings, is who doesn't want to spend, $2,000, $5,000 a year in heating oil? We have a series of high performance houses in a 5-lot subdivision in Cumberland, and when it costs $11 a month to live in it, and that includes heating, air conditioning, and all of your electrical usage, that's a big wake-up call to the $2,000 to $5,000 a year in fuel oil that doesn't include the $100 or $150 a month that you're spending in electricity. So monetarily, that's a great reason to build a high performance house. And yes, it will cost you more in the upfront to build a high performance house, but we like to explain that we'll do an energy model and we'll show you the numbers, and we can quickly evaluate how soon something will pay for itself. I'm hoping that we can get one of our solar installers to hop on here and talk about payback and the lifespan of a solar system and how quickly that pays off. It's not a simple calculation that I can just say, oh, it pays for itself in 7 years, because it does depend on your electricity rate and the area that you're in and the terms that you have. And especially here in Maine, the solar bill got passed where net metering is back, and so that's fantastic. But different parts of the country and different areas, every municipality is a little bit different on how they handle their grid-tied electrical systems and off-the-grid systems. If you happen to check out the Green Architects podcast, I know that they just did an episode with Revision Energy where they talked about battery storage. So that's getting better and better all the time. It used to be where off-the-grid houses had a whole room just for battery storage and a battery bank. And now they're getting smaller, they're getting more efficient, and it's getting possible for people to be completely off the grid, not tied. A lot of people like the security of being grid tied. What you don't think about is, oh, it's beautiful and it's sunny and I'm always going to be making power. But when you're using the most electricity, especially in these houses that are heated with electricity, is at night. So when the sun isn't shining, that's when you're using the most electricity. And so you're using heat to heat your house after dark. Hopefully the internal gains that you gained during the day. In the wintertime, hopefully you have the right types of exterior shading that allow the maximum amount of summer sun to be blocked from the windows and the maximum amount of winter sun to actually stream through and warm the surfaces and provide internal gain that helps the heating system. And then hopefully your wall systems, if you have the opportunity to aim for 30 to 40 in the walls and 60 in the ceiling and 20 to 40 in the basement and under the slab, you can keep that heat inside the house. And if you're aiming for definitely under 2 air changes per hour, 1 air change per hour, somewhat ideal. And if you're in passive house country, then 0.5 air changes per hour. And it's a definite possibility. Maine actually has a very strong passive house community here. So people looking to get to that level, there's a real possibility to be in a community full of people who are also concerned with the performance of their house, the direction that it faces, how much energy it uses, and to just cut down on the amount of energy as the population grows and we have more people and more demand. And 10 years ago, we maybe all had a cell phone, and now we all have a cell phone and an iPad and a laptop and a Kindle and any other, you name it. So we've got things that are plugged in. If you live in an older home, you have one outlet that is really inconvenient to where you might want to plug a light in or plug something in. And if you live in a newer home, all of a sudden we have more outlets that are required every certain amount of feet. Some of that is to cut down on the amount of power and extension cords that people run through their house that can cause electrical fires and other issues. But we just have more things now. And so if we can reduce our consumption in other areas so that we can pick up on the fact that we have more things, that's a great way to start to think about it. There also is this great video, and I have to see if I can find it and link it to the show notes, about vampire loads, which I think is actually hilarious. And vampire loads are everything that we have that has that little light that's turned on that's just waiting for us to come back. The cable box that's just waiting for us to come back. It never shuts fully off. The TV, the light switches, anything that wants to be ready for you as soon as you turn it on in anticipation is using a phantom load or vampire load that you don't think about. So they've created these fantastic plugs and switches where when you turn the TV off, it's the master switch and it turns all of the other things, the Xbox, the cable box, anything else that could be plugged into that off as well. The same goes for home offices. When you turn your computer off, that it would turn off everything else that would be connected to your computer, your external hard drives, your iPad, so that it doesn't continue to draw energy and electricity. But I digress. We're talking about high performance homes, and we definitely want to talk about consumption and the things that we have as it relates to a high performance home. But back to our previous thing, we wanted to talk a little bit about the building envelope. So this is Maine, and we want to try to keep as much heat in as possible. So you want to have the proper shading devices, because in a high performance home, you can have overheating even in a cooler climate like this, which is huge west facing windows that have no exterior shading. And maybe you have an interior shade that's not quite as effective as blocking it from the exterior. But if you do have an interior shade and you don't pull it down, or you didn't remember and you come home, all that extra insulation is going to hold that extra heat in as well. So you want to really think about the exterior shading on the west side of the house. You want to think about the exterior shading on the south side. So we go through a whole design process and putting the windows where we want them to be. We try to really minimize the amount of windows that are on the north side of the house, maximize the amount of windows that are on the south side, where we're going to get the best winter sun. But at the same time, when you have a maximum amount of windows on the south side, you can have overheating. So you definitely want to think about shading devices, whether that's a short porch or overhangs over the windows, or an extra long roof overhang that helps to partially shade a window to help to reduce the extra heating that comes in. But again, like I had talked about a few weeks ago, the direction and the orientation of the house is also so important. And so you really want to face the house to the south. And in our 5-lot subdivision, none of the houses really face the street. They all face south. And so we try to set them on the lots so they look between the other houses, so that your house isn't looking directly at the neighbor's house, especially when the south side is the front of your house, which might look towards the street or towards the neighbor's house. And that's where we're going to have the most amount of windows. So you're not screening your neighbors. So you want to really create this community of houses that are that work really well together, but that are oriented to the sun, the direction, and in a high performance home, that comes down to which lot you chose and how you site it on the lot. And that is actually, I would say, free. It's maybe not free depending on the subdivision that you're in. If you have a small lot and you have to face the street, you may not have the opportunity to orient the house in the direction that you want. And so then you have to get creative with your windows and your other aspects to create a high performance house. But in a lot of cases, it is possible to orient the house to the south, and that makes such a huge difference. But for us, it's not just about orientation. It's also about all of the systems and how they actually work together. So we want to maximize the building envelope because, as I mentioned previously, if you don't do a really good job on the insulation and the air sealing of the house, that's something that's really, really difficult to change in the future. So we talked a little bit about the fact that the housing stock that exists in Maine is older, and in a lot of cases, it's beautiful. They're not doing craftsmanship the way that they did back when they built some of those houses, but it's really difficult to take something that's existing and make it perform really well. Open floor cavities that allow air to circulate between floor levels, which act as exterior walls, and they cool the entire space. Really blocking and getting insulation into those cavities. There was a time when they poured vermiculite and rocks down the wall cavities. Getting that back out is difficult. There was a time when they put fiberglass and some fiberglasses into the cavities, and getting that out is difficult, or dense packing behind it isn't all that easy. They did balloon framing, and so there could be blocking in the wall. It's fascinating to take an infrared camera and take a look at a wall system that has been insulated with no insulation or some insulation, but it has blocking every 2 to 4 feet, and it's random, and it's infill framing, and there used to be a window here. Trying to get around that and get your hoses in there and really put insulation into an existing cavity is extremely difficult. So we try to inform our clients that the one place that it's really critical not to cut costs is in the building envelope, and you want to build that to the maximum that you can. If you catch the podcast before why fiberglass insulation sucks, you can catch a little bit about different types of insulation that we've talked about. But today I just want to kind of point out that the building envelope, that's the walls, the ceiling, and the foundation walls, is so critical in the performance of your house and how much you're going to spend to live in it and to heat it. I know when my husband and I moved to Maine, we were young and we didn't know anything. And I don't even recall that we had to take a home buyer education class, but we could afford the mortgage on our house. But the first time you have to put $500 in your fuel tank, it's kind of a wake-up call, like, oh yeah, we need to make sure that we have money set aside to buy fuel oil every month or 2 months. We moved in October, and so that was the start of heating season, and it was pretty much right off the bat that we needed to turn around and put money into keeping our house warm. And that was something that we hadn't talked about, we hadn't thought about. And so it was really critical for me as an architect to learn about that and think about, how do we make these homes efficient from the very beginning, not just after the fact? I talked to someone who said they built a beautiful $1 million house, and they moved in and they couldn't sit next to the windows, and it was so drafty and it was hard to heat, and it was so uncomfortable that they sold that house and they started over again with somebody who understood energy performance and can make sure that the house was comfortable. So why you might want to build a high performance house is comfort. don't you want to be comfortable in your house? I know that I grew up in a farming community in Pennsylvania. Our house was actually built before the Civil War, so in the 1700s. It was just logs kind of stacked on top of each other. It was breezy. Our friends didn't like to stay over because our house made all kinds of noise as it creaked and groaned, and the wind blew through the walls. And for us, it was kind of a joke, and my dad would just say, just put on another sweatshirt, So I grew up in a house where you sat under blankets and you wore 2 sweatshirts. And the thought of that is, there's got to be another way. So actually back in 2013, we did a complete gut job on their house. And so now they can sit comfortably in their house without having to wear, 3 extra sweatshirts. But it was something where we had to think about their dirt basement and the construction of their house, spatially framed on the inside so that we could get insulation, because their house is built out of 8-inch logs. And so when you have a log home, which is also very popular here in Maine, they're not very efficient, and you could be cold in them. I also find that log homes tend to be really difficult to light because everything is wood. The walls are wood, the ceiling is wood, the floor is wood, and the open beams, which are absolutely gorgeous, make it very, very difficult to find a place to put a light fixture. So another thing that comes into high performance homes is lighting, daylighting, using the sun as it crosses across the space. But once it gets dark, where's the rest of the lighting? All of our high performance homes use LED lighting, which has become so much more mainstream now. They're easy to get. And we spend a lot of time talking to people about multi-level lighting. Like, you may not want a full light in this area. You may want to be able to dim it. Or in the kitchen, you might want to have the under cabinet lights and the ceiling lights on while you're cleaning, and then dim that down with the advent of open floor plans. Is you don't want the kitchen to be, shining like a bright bulb while you're then sitting down at your dining room area. So multi-level lighting and how you use that, and LEDs and Energy Star appliances, also working backwards to just reduce the amount of consumption and the amount of electrical that you're using in your house. So, and induction ranges, they do require you to use a certain type of pots to work with it, but the usage of that in a high performance home, getting rid of fossil fuels, getting rid of gas, when you have a really tight house, is just something that is really important to think about. And another thing that we haven't kind of touched on yet is indoor air quality. And Maine has a great indoor air quality council where you can learn all kinds of things about additional air quality, but where that air is coming from, the fresh air from directly outside, not being drawn through your basement, not being drawn through the attic, through the dusty parts of the space, and coming directly from outdoors. And then being able to have a HEPA filter if necessary. I know it's springtime now, and so we're starting to see all those springtime allergies pop up. I was out mowing the grass yesterday and was starting to think about, oh, it's springtime now, and all kinds of allergies that are around. And so that fresh air and being able to filter the fresh air before it comes into the space, it's not just leaking through every crack or foundation. It's actually coming from a fresh source and taking out some of those allergens for a healthy house. And so why you might want to build a high performance house, for me, I think it comes down to 3 things. 1, who doesn't want to save money? 2, who doesn't want to be comfortable in their house? I know that being comfortable and talking to somebody who has lived in a high performance house and just, talking about sitting next to the window in just a regular shirt and a t-shirt and enjoying the snowfall, or you've seen people respond to it and say it's like living in a snow globe, watching the snowfall outside while you're toasty and warm on the inside. And the last is health. And this has become, sort of a ongoing thing that our country is talking about is health. I read in an article that we spend about 90% of our time indoors. And so the indoor air quality is so important. What we're trapping inside with moisture that can turn into mold. I've read stories and seen in the energy performance world about a heating system leaking in the basement and somebody not realizing and having mold growth, and then going to the doctor and everybody in the family is sick because they haven't thought about or been in the basement to see that the mold was leading to a major health crisis. Formaldehyde or other VOC products that are in everything that we have, from our furniture to our drywall, our sheetrock, our flooring, and things that are unhealthy from building products that we have in our house. Maine is a radon state. We have radon throughout the entire state. It's actually easier to just assume you have radon than assume you don't have it. And we used to have leaky basements, and that air would just push the radon out. But now that we're building tight, even just a code compliant house can trap that radon inside the house. And so the effects of what radon has, and they've been studying that for years. And so there are all kinds of indoor air quality issues. And since we spend 90% of our time indoor now, it's so critically important that we have healthy indoor air in our actual houses. And then last, with our energy recovery ventilators, we want to provide fresh air to certain spaces, and we want to exhaust it from other spaces. So we want to provide fresh, clean air to bedrooms. We don't think about it, but we spend 8 hours a night, hopefully, in our bedrooms. And so providing fresh air while we sleep is also critically important. So all of those things are reasons why you might want to live in a high performance home. And we would love if you wanted to come visit, come check it out. And we're hoping to have some of our homeowners on the podcast at some point to talk about their experience living in a high performance house, comfort, durability, energy, savings, all of those things. So anyway, that was our little spiel on why you might want to live in a high performance house. If you have anything that you'd love to hear us talk about, or have somebody from one of our colleagues come on and give you more detailed information, certainly we are happy to do so. So just post something in the comments, and we would love to hear your feedback. Thanks, and have a great day.